introduce speakers. So yeah, I will introduce Adrian. I just picked him from airport straight here. Adrian is a coach. He is facilitating code retreats for 5 years, and this time he will be facilitating code retreat in which tomorrow in Fujitsu. Well, it's too late to sign in because security and all the stuff. We had to close the list yesterday. But next year I invite you. Maybe we'll have Adrian. Maybe we'll have his brother who is also facilitating. And I will let ask a couple of things about you to yourself. And thank you for coming. And I hope you like new location. Maybe we will do joint meetings more often. Please welcome Adrian.
Thank you. So this is me. I'm doing programming, training, and coaching, depending on the time of the year what my customers are doing and so on. So I do a mix of those. I will talk about legacy code. How much time do I have?
Well, we have 1 hour, so
that's a lot. So probably I'll talk 20 minutes about legacy code, and if you want to, or 25, not more. I tend not to like talks that are longer than 30 minutes. I tend to stick to 20. So if you want to discuss more, I'm open to discuss more, but I'll just present you my thoughts on legacy code. Okay, so I have 2 scenarios in mind that I saw in many companies. Some of them I helped, some of them didn't want to be helped. So I have like a current situation where you have legacy code and things are not that nice. And that means for me not knowing what the code actually does. And I have a better situation, not the best, but better situation where I greatly understand the code and I change it more and more, but just to the point where I can fix business needs. So if I have this code base, this legacy code base, what would be the reasons to change it? So often people tell me because it's crap, because I don't like it, because it's ugly. But if you want to add business constraints into that and risks, I found these 3 possible ways, possible cases to change the legacy code. First of all, if you want to fix a bug, okay? You want to fix a bug and it's very complicated. The code is a mess and it takes days, weeks to fix it. Either because you don't know where to start with the bug, or it's so difficult to change the code, so it takes a lot of time. Or you want to add a feature, and you say, okay, it's very simple, right? I just add the button, and then after 3 weeks, nothing's done, because the code is so difficult to change. That's the second case, where it makes sense to change legacy code. And the third one, if you want to have automated tests for the system core. And by system core, I mean that part of the system that is so important, that connects everything, or the part that if it fails, let's say, your company might go bankrupt, or the company you work for. So it's very important, it's very risky to keep that part untested. And as I said before, these are not reasons to change the code. If I don't like the code because it's ugly, it's not enough. You need a business case behind it. Or I saw that, I would like to see nicer code. But this is very, very often the case. Yeah, I want to update to the newer version of I don't know which framework, or I want a new library that's very nice and so on. But that doesn't really bring business value. It's nice because want to play with these things, but it's a lot better just to do this on a pet project than do this on legacy code and create a complete mess. So let me go back to, let's say, a current scenario where you have this legacy code. And there is this serious cat coming to you that says, you know, I want you to do this feature. I want you to do this now, and we are late, and we want it got done yesterday, and so on. So if someone comes to you and says, yeah, these are the features, like a manager or product owner or product manager, whatever. And, well, you have a very short time to do this, right? You have this very serious admin cat that says, you know, this is very serious and we need to finish it now. But what happens is that you look at the system and you see something like that. You know, I don't know how to do this, and you're afraid. You look at the code, it's crap. They want you to finish it yesterday, so it's very, very difficult. And the time feels very short. It's very, it puts a lot of pressure in. So what would every reasonable person do? You'd say, well, no, sorry, I cannot do this in that amount of time. But typically what happens is that managers are extremely positive and say, yes, we can do it. Of course. Of course we can do it because we are good and we have, I don't know, tools and people, and of course we should do that.
And it will be ready tomorrow.
Yes, and of course it will be ready tomorrow. So these are things I saw maybe tens or hundreds of times. And it takes at least double the time set. I said here double just because I was nice. Often it takes 10 times, 15 times, 20 times the time you said initially. In my view, estimations on working on like something like this, on legacy code, don't have any sense, don't have any meaning. When someone asks me, how much time do you need to change this legacy code, I typically tell them something like between 1 day and 9 months. So if you're okay with that, then let's try and start this. But if you come with something smaller that we could work with, yeah, maybe I have a shorter interval, but I always give estimations in interval and not something like 2 days or 5 days. Or, I don't know, it depends. There's so many things there. Anyway, what happens typically is that your company loses money, your customer loses money, and people tend to be upset. Okay? And this is because of pressure. And everyone is stressed, and yeah, things like that. But what we can do differently? If someone says, yeah, let's try to add some features to an existing product, someone signs a contract on this. What you can do is try to understand techniques of legacy code and try to use those. Try to understand the code before really giving that estimation for the contract. And if you have a manager or product owner that really cares about these things and cares about the customer, they will first ask you, look at the code, try to work a bit on it, and then tell me what do you think about this. Is it difficult? Can you do it yesterday, or do we need 9 months? Does it make any sense to make a commercial offer? So this is what you do. You start writing these things called characterization tests. Have you ever heard about those characterization tests? Someone? Someone?
Is it BDD or?
It's not BDD.
How it behaves right now.
Sorry?
That's how it behaves right now. It should be the
Exactly, yes. So these are, the name characterization test is was coined by Michael Feathers in the book Working Efficiently with Legacy Code. And basically, Michael says, we have this code base and we write tests on it, and we just want to characterize the existing system. Those tests can be of different types, different sorts. And why do you do that? Because you want to see how the system is behaving now, what it's doing now. And if you change something, you want those tests to help you. So they become something like a safety net. So that if you change anything that you shouldn't have changed when you add a new feature, then you see them break and you go with back. And in this way, you don't introduce mistakes or bugs. This program was called them. Characterization tests can be of different types. So, do you know about the pyramid of tests?
Yeah.
Yes. Does it make any sense to draw it, or you know it and
I don't know.
you don't? Okay. So, what's the pyramid of tests? It says like that, and you say, okay, I have pyramid basis. I have pyramid basis, some unit tests. I have here on the top manual exploratory. And in the middle, I have other types of tests. Like here, I could have something like integrated tests. I could have some other tests like performance, security. Okay. Maybe some automated UI. And others. It depends on your context. But, and yeah, maybe integration tests.
So those on the top you execute less often?
Yes.
Okay.
You have
Less.
the idea of this thing, unit of test, is that unit test is good to have to be around 60% of the whole types of tests. Why? Well, I'll tell you why a bit later. These integrated tests are what you call feature tests, or tests that go through all the systems. Start from a database, go to business layer, go to another service, go back to another service, and then send you back an answer. So integrated test means that they integrate many systems for having a feature. Performance, security, these are special, and they depend on each system. Sometimes you need them, sometimes you don't. And integration tests are the tests that you want to do on integrating with some other system. Like I have this web service, and I want to make an interface with something else, and then I want to write a test on it, like just on the layer of integration. Automated UI, that means you test only the UI, the automated tests. That's simple. And manual exploratory is just what testers tend to do, just to look and feel and see how things are going, explore if the product makes any sense from a user point of view. So these characterization tests typically start from here, from the integrated test. Because when you have a legacy system, you cannot really have interfaces or have a design that helps you break things easily. So these integrated tests are this safety net, but it's not enough to stop there. Because if you want to reach this pyramid of tests, the idea is to start with these, then write some of these integration tests on the layers, and then start breaking the big system into smaller components. And then, yes, and then you will have another test that typically is not on the pyramid, but I'll write it anyway. It's called component test, which is a kind of a test that you write on a component like on a black box system. Just want to see, okay, if I give this, what will I get back? So having this big system, I break it into components, and then I test individually the components. I keep these as a safety net, and then I have a two-layered safety net, one of the integrated test and one of the component test. And at the end, what happens is that I tend to want to refactor some of those to have unit tests. So I break them smaller and smaller, and I write more tests just on the units, on the classes, on the functions, on the very small structures. And this is why I'm saying this, because characterization tests at the beginning can be any of these: unit, integrated, component, integration. It depends on your design. If the design is loosely coupled, then you can immediately start writing unit tests, and that's great. But if your design is very hard coupled, you will write these, and you will need to apply techniques, legacy code techniques of breaking dependencies. So this is why I wanted to dive a bit into what characterization tests are, because it's not that clear usually. So this is the idea. You start writing characterization tests to understand the change. What does it mean? I want to add this feature. Which component this new feature affect, and why? How much? And then you start writing these end-to-end or integrated tests. Okay. You want to start them, but you want just to understand which are the external dependencies. External dependencies means everything that you don't own. If it's a framework, if it's a library, if it's a web service you call it, if it's a database you don't. So everything like that is external dependency. It's not code. And typically these things are slow. So you want to test them together, and then you want to decouple them from your system. Because in this way, you can go towards unit tests, which are very fast to run and give you very fast feedback, compared to these kinds of integrated tests or these end-to-end tests, which are even bigger, that are very slow. And they are helpful in the beginning, but if you add 20 a day, then after 1 month, you won't run the tests anymore, because they will take hours to run. So this is why you want to refactor those things and to extract the external dependencies. So what you do is you split the end-to-end test into integration tests and unit tests. You have these integration tests on the boundaries with the external slow systems, and you have inside you start writing unit tests, which are very fast. Then you start adding unit tests on the cases you don't have coverage of. For this, typically we use tools for test coverage that show you the branches that are covered and the branches that aren't. And you don't want to cover everything with tests. This is why I said at the beginning you want to see where the change will affect your code. So if I want to plug this in here, I don't want to test here. It doesn't make any sense. I want to do this kind of testing as less as possible. So if I want to plug this in here, I want to make room here, and I want to start writing tests on that area so that when I want to plug the feature, I can change the code in such a way that I don't introduce defects. That's the idea. So I start trying adding more unit tests by looking at test coverage. And I start refactoring the code in such a way that I'm happy with the quality of the code. And I improve the design so that it's loosely coupled, it has good names, and it makes sense for that feature and for the business I'm working on. And then what do you do? Well, you made enough room for the new feature. Basically, that's the idea. And you add a new feature. Now, this, for me, means test-driven development. So I add a new feature with writing tests first, and I develop it like that. This gives constant feedback, and I'm sure that what I developed so far is correct. And at the end, what I have is a fully automated, fully test-automated, test-covered new feature that is plugged into a system that's a bit clean, where I plugged it in, and very messy on the rest. And that's fine. Because my purpose isn't to clean everything. My purpose is to add a new feature as fast as possible so that I bring value to the customer. And then you give this to your testers and they do this part. It depends, right? They might do only exploratory testing, they might do some automated UI tests, maybe they want to do some performance and security if they have the skills on that, or you leave that to someone else. But they do some exploratory tests, some automated tests, some manual tests. And this is where the feature ends. Again, the pyramid of tests, but it was more useful to explain it at the beginning. Now, if you had if you took the time from the beginning to look at the code and to work a bit on it, you can have faster feedback and you can understand how much time it takes in some interval. And you can deliver on time. But if someone comes, you need to do this tomorrow, you will never deliver on time. And that doesn't mean only that you are unhappy, it means that the customer will be unhappy, and it means that you do bad business. Not only you, but your whole company. So that's really a bad situation. But so when you deliver on time, what happens? Your company wins money, wins respect for your customer, and you start having a trust relationship. But now, the main problem is, and this is why the talk is called Legacy Code Sphere, that the things we don't know, our unknowns, are making us afraid. If you don't know all these techniques on legacy code, how to write characterization tests, what are those tests, how to look at them, how to break dependencies, how to write unit tests, how to do test-driven development, right? Those things help us be, let's say, less scared. So if you don't know these things, then what I recommend is try to learn them and try to automate as much as possible from the acceptance part. By automating those tests, we can increase confidence because we have a fast feedback on our system. We can always ask our tests, is our system delivering what it should? And they should be fast, not hours, not tens of minutes, but minutes. So, very nice. Okay, how do we do this? Probably you're asking. And now I will go on, let's say, what I typically do with companies in this situation. I go out and talk to the teams. If you have a legacy code system, if you work on something like that, well, probably they know what they don't know, to some extent. And there can be so many things like domain knowledge, programming languages, right, unit testing, acceptance testing, some frameworks. So many things can be there. Then just ask them, and then make a list. I look together with the managers and we decide the priority of these things. What is the most important things to start with? And then I use a smaller problem at first. I say, okay, let's not try this technique. We learn, how to break dependencies in one way, let's say. Let's try not to use this on the big legacy code project. Let's try to use this on a smaller problem, just to understand how things work. And try to write characterization tests, for example, and then try to practice these techniques. For example, coding dojos or more programming or things like that that help you practice together. And the more you practice, the more you gain knowledge, and the less you are afraid of legacy systems. These experiments need to be a safe system to learn. A place where you can fail, a place where you can do things wrong, and they won't cost you anything. That's basically the idea of having an experiment rather than working on production. So whenever you want to learn a technique like this that is not that easy, try not to apply it in production immediately. Try to practice it. And when you feel comfortable, try it on a smaller project. And then only try it on a very big project. When you learn things, they take time. When you learn complicated things, they take more time. And that's just natural. Do you know Dune by Frank Herbert?
Yep.
So, this is from Dune. This is the litany against fear. And there is this gang there of Bene Gesserit nuns, and they can live without fear because they know how to not to absorb fear, but let them pass through them. And this is one way of looking at fear in a more relief. But it's very important that fear is the mind killer. And when you are afraid of something, you will do mistakes. You will act irrationally. For programmers, we are afraid typically because we don't know techniques or languages or things like that. And we can learn them. So that's the idea. So, for me, the litany against fear in software is to invest in the future business agility of your company by learning more and more things like that. Learn how to deal with legacy code because that's the most difficult problem I see all over and over again in companies I work. And it's not easy. It's not like, you take a book like Michael Feather's book and you read it and that's all. You need to practice a lot and you need to learn a lot. And this is the word. The litany against fear. The word is learn. Find the unknowns of the team, as I said. Make a learning program. Medium term, not just for next week. Try to make it for 6 months. Make small experiments, learn, then extend to bigger scale experiments. Learn again, find out where you went wrong and so on. And only after that, do a small change in the production system. Other way, what you can do is try reading this book. It's very good, but it's very technical. So Michael wrote this book because he loves design, and he thinks everyone knows design, and everyone knows unit testing, like they were born with it. And this isn't really the case. So it's not that easy to read. It's very good, but you need to take some time to understand what he's talking about. If you want to be faster, find a trainer to help you learn faster. You can do this by your own, learn it. It will take a bit more time. If you want to invest some money and be faster, then find a trainer. But it's important to have this learning program with team or trainer or just with the team. That's very important. I wrote about some of these sessions on my blog post, and I have some 16 codecasts, I think, in Java with some of these techniques, and you can find them on my blog. So I have a blog post for each technique, like written, and a codecast, that's video, of me doing that technique. That's like, you know, trying to read this and then practice by yourself. So this is what I'm trying to say here. Learn this. These are some ways of learning, but there can be others. But the main idea is to practice. And the more complex the system is, the harder it is to break it. And you need to be more fluent in those techniques. So as I promised, I was done faster. If you have any questions.
Well, I have a few maybe, but I have a lot of them. At the beginning you said that some companies didn't want to be helped, and can you explain why they didn't want it, or they didn't like the approach? Or?
Because they have very good programmers and they know how to do this.
Mm-hmm.
That's the answer.
All right.
And when you talk with the programmers, they say, I don't have a clue. That's why.
So is it in if you're signing a contract, is it in a contract that you'll be spending like the first portion of the time on like extracting all the things and then implementing the feature after all? Because you will not be delivering for some time when you're dealing with legacy.
It depends on how you want to work. There is a model where you start looking at the code before signing the contract, and you say, you know, if there is trust between the two parties, and you say, oh, I want to look at the code, try out some things, see how complicated it is, and I'll give you an answer in 3 days, or in 4 days, or in a week. Depends on how much you want to change or how many things there are there. There is another model where you can say, look, now the contract will say I will try to implement those features, but I don't know yet when. So give me a bit of time, you'll pay me for this. The first thing is, the first type, what I said, is just trust. So you're not paid on that. You're not paid on the discovery. Here, when you sign the contract first, you are paid for the discovery. And then there's, okay, you want to look at the code and see what's going on. And yeah, of course, you won't be delivering that during that time, but that needs to be short. It's not like taking 3 months to look at the code base. A couple of days is enough to understand for some features. And you don't want to start with all the features at once, so you want to prioritize and ask them, okay, what do you want to start with next? Give it 2-3 features. And 2-3 days is enough to look at the code. So yeah, you won't be delivering for a couple of days. But anyway, you won't be delivering, so that's not a problem. The idea is that on the medium term you're faster and you don't introduce defects. So you are less expensive because of that. That's the main goal, basically.
Can you tell us what aspects of mob programming do you find useful for working with legacy code?
Well, mob programming is about a team sharing things. And it's useful with any group that wants to learn things from each other. If it's legacy code, if it's design, if it's unit testing, anything you want. So programming languages or so on. It's useful because you see how other people think. You see the code shaping up in front of you on the projector. And it's very useful when you start seeing the code and and see how it changes. And you learn techniques, not by doing them yourself, but by seeing them live happening. And that's where I find it useful. But you need a team that is mature and they can work well together. If not, I prefer coding dojo.
Can you explain the difference? Because, yeah.
Coding dojos are of, well, let's say 3 types. Okay. There is the Randori coding dojo. That means someone, like the sensei, comes in, does some stuff, like refactoring legacy code for half an hour, and then the group says, okay, do it the same as I did on your computers. It's like martial arts, the sensei comes, shows, this is how I do these things, and then you do it yourself. And I'll tell you where you're wrong or where you broke something. Then there's another one where you have a projector, and you have like between 5 and 7 minutes per attendee, and they cycle around the projector and they write code. And you have a facilitator who makes sure they are on the good path. But everyone needs to write code. For this you need a small group, around 5, 7, maybe 10 people, because you want each one of them to cycle at least 2 or 3 times. And if you have 7 minutes, yeah, you don't want to have more than 2 hours, so basically that's why you want to have a small group. And then there's the third type where you have, like in a code tree, just pairs, start with a problem, do it yourself. This is the constraint. Refactor this legacy code. Use, I don't know, some types of tests. Try to write a characterization test on the code on that function. And I'll help you as a facilitator. More programming is different because you have a person sitting at the keyboard, and there's a group in the back, and the person writing on the keyboard is not allowed to think. Okay, it's just the hands of the group.
Code monkey.
No, it's not Code Monkey because Code Monkey is just typing without understanding. But the group is telling the typer what to do. What to do with the code. And it's basically more like a group mechanics exercise. And it's very useful for teams that are mature, as I said. Because if not, someone will say, I want to do this, no, I want to do that. And then you'll argue over things. They can be close, but they are very different. Okay. Anything else?
Are you using any measurements when you are working with legacy code, to check, I don't know,
Typically, I do static code analysis with a caveat graph, showing average depth, maximum depth, cyclomatic complexity, average cyclomatic complexity, percentage of documentation, percentage of comments, something like that. So all this on a caveat graph.
Do you find this easy to explain, let's say, to managers, those metrics, or you need to use some kind of metaphor like technical depth?
Well, typically, if I have a code if I want to change the code in one place, and I need to plug in that feature in that place, and I have a very big number for average depth and for average psychometric complexity, that means it will take me a lot of time to refactor it. If it's not that big, then I tend to look more on the code and see how I can change it. So it's just the first glance on what can I do with the code. And then after that, I use checkpoints. I do checkpoints to see how it evolved. I want to go to a certain, not too far away, but I want to go somewhere where the code can be changed easily without the risk of introducing defects.
Yeah, but I think the question was, do you explain to executives that, okay, cyclomatic is very big, or you just...
Sometimes, it depends, yeah. It's so variable, so I just explain them the code is complicated and it takes a lot of time. It's not, it depends on the manager, okay? Do they know what that is, or they don't? If they don't, I talk their language. If they are technical, then I explain them and we get along. So it depends on the person I'm talking with. But it's always a good idea to tell them what that means and to give them a measurement of how complicated their code is.
Just last question about legacy code retreats. So
yes.
Because when I've heard about legacy code retreat, I said, first of all, it must be boring, and second of all, it must be very difficult because, well, maybe I'm not very familiar with legacy code retreat format. Do you delete code and you have 45 minutes to do something?
Yeah,
Start from scratch.
there are facilitation styles like this when you have 45 minutes. There are also some changes in the project formats where you take the code and you keep the code, in fact. We tried out different things. I'm not yet sure which one is the best, even after 3 or 4 years of doing that.
But is it boring?
No, for me it's not. For me it's very interesting.
And is it difficult?
Yes. It is difficult, but you need, what I typically see with programmers is that this technique, let's stop here, they don't stop. They want to refactor it more than needed. And that's the most difficult part. Because that means that if you refactor more than needed, the more you change code, the more you have the risk of introducing defects. That's the most important thing. And then the second thing is you lose time. That change you do more from here to there doesn't bring value to your customer. So stop. And that's the most difficult thing. But it's also difficult to get in the mindset of this is legacy code and how the hell do we start, because we don't have any tests and you're not allowed to change the code and to touch it. So how do you do that? That's interesting. So it can be very difficult sometimes.
Can I have one?
Have you ever had a situation that you had to reject the project due to complexity of the code, or the lack of the documentation, or the misunderstanding with your manager? Yeah.
Yes, because as I said, they want it to be very fast. So if it's
so it was rather lack of the time, yeah.
Well, the time is fixed. But if you don't have documentation, you don't have anyone to talk with. It's only the code, and if I just look a bit at the code, like what I told you with some static code analysis, and I see it's very complicated, and I see, it won't be done in 3 weeks, and they're not happy, then okay. If you find someone else who wants to do that and takes the risk, fine, but I won't do this.
Thank you.
I'd like to get back to the characterization testing, but it's sad because, well, it seemed like a good idea to focus on the one part you'd like to change, for example, to introduce a new feature. But from my experience, the problem with legacy code is that there are very strange creatures. And like you could write your test, you take some time for it, you learn the code, you learn to trust your test, you implement a new feature, the tests are green, everything is fine, great. But in some magical way, like 2 weeks later, it turns out that your change crashed a completely different part of the code, or even multiple different parts of the code. And then you come to a conclusion that I cannot really trust those tests because I would need to test the whole system in order to trust them.
Yes, that can happen. This is why I said the more you change the code, that's legacy code. So you are sure that that part of the code will be okay. As long as you don't have anything for the rest, you don't know. So you cannot really test everything. You can do some sort of very kind of a safety net for the rest. It depends how big it is, again. Because if it's huge, you really cannot do that. So it's always like that, but it gives you confidence that in the part where you changed it, you don't introduce defects. It's very possible that you introduce defects somewhere else. Like a friend of mine told me he worked at IBM, and he saw a label somewhere in an HTML form that had the wrong name, changed the label, and then all the system crashed. Why? Because the name of the label was connected to some table in the database. How the hell can you test that? It's just not possible. That's why I said here that you want to do some exploratory testing. So this is very important that, where was it? It's very important that you don't just focus on your tests. You want to do some exploratory testing and some manual tests. It's not enough to have only automated tests. And yes, if the system is very big, this will take a lot of time, but you want at least to see if the main features work well.
So would you, for example, recommend in the example that I give that we found the problem in a different part, we fix it, we write another characterization test for this part, and just move on to the next feature, begin with the same, and like in this iterative process, our net of tests grows. Is this a good approach?
Yes, exactly. That's the idea. But in the beginning, you will have risks. The more you cover with tests, the less risk you have. You will still have risks even when you have many tests, but not that many. It shrinks to less and less. So it depends a lot on the project. There are many techniques that can help you test everything, like a black box for the whole system, but they are typically brittle ones. And it depends on how big the project is. Okay.
Any other books than Michael Feathers? Because
Unfortunately, there isn't any other book than Michael Feathers. Michael was very crazy to write a book on this, but but I don't know anyone who wrote anything else about this. But you need to take into account that if you want to do this, you need to understand very well software design, software architecture, automated testing of all types and sorts, manual testing, and that's a lot. So if you want to read that book and really apply it, read all the books about design that you know, all the books about architecture you know, many books about unit testing, test-driven development, other types of tests, testing, design. And
10 years later.
And a couple of years later, you'll be very confident working in this way.
So it means nobody here is able to even touch the legacy code because we don't have competence to do this.
Yeah,
I don't know.
it's very challenging.
And in gloves.
It seems so.
Yeah.
I don't know.
If we are not able to read the book with understanding, it means that
Well, it's a gradual understanding. Like you can read that, and you'll understand some things. But if you read a lot of books on design and try out design techniques and so on, then you'll understand. This is why he said you want to do this. So you'll understand more and more. And it's not that you don't understand anything from the book, but refactoring means that you want to structure the design of the code without changing the feature. Like the outside behavior of the system. And for that you need to understand what good design is. So, refactoring legacy code means I start from this crappy code and I go to this good code. But what is good code? That's the idea. If you know what good code is, great, do that. Okay. Anything else? You can find the slides here, slide share. Okay? Thank you.
Thank you.